So, hello everyone. I know today is a bit late while uploading the video because I was busy today shifting my flat. So, let's see what today's question is about. The name of the question is count number of free cell. And before starting the question, if you are new to this channel, please like, share, and subscribe so that we can maintain and grow our streak together. So, let's jump to the question. So, it's an easy category question. So, what it says is that given a matrix size of n cross n, and an integer k, initially the matrix contains only 0. Okay, you are given k task, and for each task you are given two coordinates r comma c, that is one based indexing. Okay, so where the coordinates r comma c denotes the rth row and c denotes the cth column of the given matrix. Okay, so you have to perform each task sequentially in the given order. For each task you have to put 1 in the rth row cells and the cth column cells. Okay, so this question is actually seems easy, so let's read further. So after each task you have to calculate the number of zeros present in the matrix and return it. Okay. So for n equals to 3, there are n equals to 3 cross 3 matrix, there are three subtasks, and it is given as 2 comma 2, that is nothing but 2, the second row and the second column. And after the first operation, all the second row and second column will be filled by 1, and so the remaining cell with the 0 will be 4. Like they are saying as 4, we'll verify it. After the second operation, the second row and the third column when filled by 1, the remaining cell with the value 0 will be 2, and after the third it is 1. So you have, for each and every subtask, you have to print that the number of cell remaining which having the value 0, right? So let us see before proceeding on the question. So the constraint is n is like n is n is 10 power 5, and for 10 power 5 complexity, let's refer to a chart again. The maximum time complexity we can code is n root n, and you can go below that, that is n and log n and all, right? Because n root n will be like the just the lower bound, hitting the lower bound of the 10 power 8. So if you do not understand 10 power 8 logic, I have made this video on time complexity, that is how to trick the TLE. So you must watch this video. It must be flashing up here now. So let's come back to the question again, that in which time complexity we should start thinking. But before thinking, let's do a dry run, because after doing a dry run even itself, many things are clear. So let's make a 3 cross 3 matrix. 3 cross 3 matrix. So initially everything is 0, right? So let's make it 0. Let's make it 0. And it is saying that you have to do 2 comma 2, right? The second column and the second row. So let's process it. This is the second row and the second column, right? So as you can see that the remaining cells are 4, right? Remaining cells are 4. And before like doing this, all these things, that how many cells marked with 0, before doing any subtask, you can say that, let's say my current result was nothing but n cross n, right? N cross n, right? And my row was equals to 3, and my column was also equals to 3, but which is nothing but n, in this case, right? So what I did when, how this 3 cross 3, that is 9, 9 becomes 4. How is that possible? So what I'm saying is, while I am marking the one row and one column as 1, right? And I'm calling for rest of the things, the value which is 0. So I guess let's proceed on with the further subtask, and maybe we'll be able to derive some conclusion. So now the matrix is looking like it is 0, it is 1, 1, 1, this is 0, this is 0, this is okay. So second row was marked to 1, right? So this is 0 and this is 0, and you can see that the number of 0 here is 4, right? And that is why you are getting the 4. The second operation is about 2 comma 3, right? So 2 comma 3, it is, so this this cell and this row was already marked, so it is saying that you have to mark again the same row 2, and an unvisited column, that is 3, right? And you can count the number of or if I just may if I just write the matrix for you again, what's the updated matrix, it will be 1 1 1, it should be 0 1 and 1, right? So now you can see that the number of zeros available is only 2, and that is why the 2 was our second answer. But the last subtask is about 3 comma 2, right? So 3 comma 2. So what was the rows and column earlier processed? This was processed, right? This was processed, this was also processed, and this was also processed. So the new thing that we have to process is 3 is already visited, 3 is already visited, and we have to mark the second column. So actually 3 is not visited as of now. So the 3 will be visited this time, and 2 is already visited, right? So I can see that the number of remaining zeros is just 1, and you can just print the answer, right? So that means you can see that there are times when you have to mark a row, which is already visited, right? So that means you have to make some a vector, or let's say set, to say to always check that if that visited is if that row is already visited or not, right? So let's make a two set, one for row and one for column, right? And what can I see here is in the first iteration the r and c both was equals to 3. R is 3, I'm saying, because there are in each row there are 3 elements, and in each column there are 3 elements. That is what r and c is representing here, right? What can I say is that if both are unvisited, if both, let's say I'm making this as x and y, if both x and y are not visited, then I can say that you have to, in each row there were 3 elements, right? And in each column there are 3 elements, so you have to remove those elements, right? And if both x and y is not visited, then that means there must be this thing, there must be one common element, right? So suppose we talk about this thing, this is this thing, right? If we talk about 2 cross 3, and suppose nothing is visited now, right? So if this is the second column, this is the second row, and the third column, you can see that this is the common element. So you take any combination, either 1 cross 3, 2 cross 3, 3 cross 3, assuming that none of the rows and columns are visited, then you will have one common element, right? So that means my current result, or let's say I'm saying current CR, is nothing but updated as minus of R, the elements, number of elements in each row, because I am removing one row, right? I am removing one row and marking as 1 the number of elements in each column, and then plus 1 because there was one common element, right? So this will be the formula, and if you just put the values, it will be 9 minus 3 plus 1, so it will be like 4, right? And since you have removed one row and one column, so since you have already visited, then that reduce the number of rows also, because since you have removed the one row, if you have removed the one row, let me write it like here, it is 0 0 0 0 0 0 0 0 0. If you have removed one row, this row is removed, right? Then each column is having two elements, right? So I will say that column minus minus. And similarly, if you have removed, let's say I will make again 3 cross 3. If I have removed one column, if I have removed it, then each row is having two elements, right? So I will say r minus minus, right? So that this pseudocode goes for if both are row and column is not visited, the index is the row and column is not visited, and these are all the operation we have to make. And similarly we will make a set here. So let's define for this thing also, when row is visited and column not visited, and vice versa. So when we call for 2 comma 3, the 2 was already visited and 3 not. That means that the row is not visited, right? So what can I say is, what can I write is that row is not visited, right? Then what can I say, that for each column one element will be removed, or let's say gone, will be gone, right? So how many total columns are there, right? So I have to remove the number of total common columns in my current result. So I will say by my current result is nothing but the current result minus the number of columns, right? And since this is the point 1, and since I have removed one row, right, then the point 2 will be that you have to do row minus minus. If we dry run this pseudo code, then let's see our answer matches or not, because we have to think in the code perspective also. So it will be like the earlier CR was pointing to 4, right? So it will be 4, and C minus minus is nothing but it goes to 2, and R minus minus goes nothing but goes to 2. So it will be like 4 minus 2, that is 2, right? And this is my answer for the second subtask. So we are on the right track, and the R minus minus, that is, it is updated to 1, and the C is still at 2, right? And if you visualize also, if you like visualize, then if you visualize also, then what is happening here is that you have marked this state, you have marked this state, you have marked this state, right? So for each row you can say that there is only one element. For any row, if you see, there is only one element, and that's what it is saying. For any row you will be having one element, and for any column, so there is only this column, this first column remain, that is not non-visited, and you can see there are two elements left, and that is what this is depicting, c equals to 2, right? So let's form a third test case, third subtask case, where it will be saying that column is not visited, right? And what is that, which is that case? The case is 3 comma 2, where you can see that the column was already visited. And am I right? Am I saying right? Let me see. Okay, so in our second subtask, the column was not visited, right? So the case which I just discussed here is for the row not visited. So let's discuss for this second subtask again, right? And I'm saying that the column is not visited, right? So for column not visited, uh, yes. So for column not visited, so the column not visited for this second subtask, right? So for this third subtask, you can say that you can see that. Okay, so let us assume there was some problem there. So for the second subtask, I was saying that the column was not visited, right? 2 comma 3. So if column is not visited, then that means if I make this column visit, then you can see that for each sub row, this one element will be neglected, will be removed, right? Will be removed. So what can I say? That for each row, one element will be gone, right? So how many rows are there? I will update my current result as current result minus the number of rows. So it will be, the row is pointing to 2. So 4 minus 2 is 2. And since I have visited one more column, that means that the remaining column I have is, we have to decrease it by 1. So c minus minus, that is 1. And the remaining row is 2. And you can see that the remaining column that is to be unvisited is this first column, and that the count as 1. And the remaining rows that needs to be visited is two rows, that is the first row and the second row, right? You can see there are no lines crossing it. So that is it. So this was the case of the second subtask. So let's move on to the third subtask, where the what where the row is not visited, where row is not visited. You can see that the 3 comma 2 in the 3 comma 2, we have already visited 2 right here, but we have never visited this row. So if row is not visited and we are making a row visited, let's say we are making this row visited, right, this third row, then that means for each and every column there is one element reduced, right? So I can say for each column, one element is gone, right? So my current result will be updated as my current result minus the number of total columns I have, right? So it will be 2 minus 1, because the from the just previous iteration column was pointing to 1, so it will be 1. And as you can see that this is the answer for the third subtask. And since we have row is not visited, and since we have visited it, so we have to again remove one row, right? Decrement it by 1. So row will be finally pointing to 1 and C will be finally pointing to 1 after this third subtask, right? So now let's get ahead and start with this coding section. So I hope these all three things are clear. I will just code this approach, right? And to check that if the row and column is visited or not, I'm maintaining a set for row as well as a set for column, right? So let's make this. So what will be our global steps? The global steps will be that this will be our first step to declare a set, second step to declare some variables, that is r, c and current result, right? And since we have to return our answer in an array, so we'll make one result array, let's say of k size we'll make it, and this will be all in step 2. And then we will just iterate for each and every element, for each and every subtask, and we will include these three ifs: one if, and this is two second if, and this is third if, right? So let's get started with the coding now. So okay, so if you have completely understand this dry run, then it will be very simple to go ahead with the coding session. So let's go ahead now. The first step was to make some variables, so let's make it. So it will be, first we'll making a set integer. It will be uh, for row, right? I will say new hash set. Similarly, I will make a one new hash set for column, and I will paste it again here, and I will say col, right? Then step 2 was to just initialize some variables. So initially my row remaining is 3, or if I just say it is n, right? And the remaining column is n because none of the columns or rows have been visited now. So the remaining rows and columns as of now is n, right? So we have to return this thing in a long array. So I will make a long, or I will name this as long answer, that is new long. So that will be new, okay, new long of size n, of size k, because there are k subtasks, right. And I will, one more variable I will say, that is current result, which I will store the answer for each and every subtask, and it will be, as of now, it will be total number of cells in our matrix, right. So step 2 are, all the step 2 are completed. So let's move on for the step 3, and that is nothing but we will iterate for each and every subtask. That is for int I equals to 0, I less than, how many subtasks are there, it is k, so for I plus plus, right. So what I will do now, that there are 3 if statement, right. So if both the rows and columns are not visited, right, so you have to store the current row which I am standing at, that is int x is equals to array of I of 0. The first entry is the current row, right, and the second entry is current column. So I will just store it in a variable, let's say y, and I will say 1, right. And then what I will do, I'll just run the all the 3 if statement, that if set of setting, if row contains dot contains x and column dot contains y. So if both are not visited, then what we have to do, that we have to update our current result as current result is equals to current result minus r minus c plus 1, right. And you have to decrement the number of remaining rows as well as the number of remaining columns. So that is it. So let's write the another if statement, and this we will just reverse the inequality, right. That let's say if the column is visited and the rows are not, right. So let's say if the column is not visited and rows are visited, right. So what we were doing, that if the column is not visited, we subtracted the number of rows and decreased the number of column. So I will do subtract current result by the number of rows, right, and reduce the number of columns because one more column has been visited now. Similarly, the third if will be there, and it will be that the rows is not visited and the column is visited. These are only the 3 cases that this subtask will encounter. So I will say that it is nothing but you now have to remove the uh, mm, number of elements that is equals to column, and you have to remove, since the row is not visited, since now it is visited, so you have to reduce the number of row by 1. At last, we just have to store our current result in in the answer, where in the answer array we just made up there. So it will be answer of I is equals to current result, and then you have to mark, when you process a one subtask, you have to mark that those rows and columns have been visited, right. So I will say that row dot add x and column dot add y. So that is it, and at last I just have to return result or answer. Yes, that is it. So I guess everything seems correct to me. So let's compile and run this code, and we'll see for ourselves. And what will be the time complexity of this code? We are just running one for loop, so it will be O of n. So there are some couple of spelling mistakes. Let me correct it for you. Okay, n star n, there is no n star n, that is capital N, right? So let me replace it with capital N. That is it, I guess. So let's compile and run again. So great. There is some error again. We need to do something about it. So let me look at it and then we'll get back. Okay, so we have this mistake here, as we have written the same if here at line number 65, right? Whereas it should be pointing as it should handle in the case of the row is not visited and column is visited, right? So uh, these were the statements running for this test case, that row is not visited and column is visited, right? So let us compile and run again in hope that we will surely pass this test case now. Let's wait for the results. So great, our output and expected output matches. And since the code is written in just one for loop, that is O of n, O of k actually, right? O of k actually, and rest of the things are we are doing in O of 1, right? We are just checking in row.const, that is O of 1 and everything, right? So it should be, the time complexity of this code will be O of k, right? And the space complexity, what would be the space complexity? The space complexity would also be O of k, right? We are just adding those indexes as soon as we are getting in our subtask, right? So it would be O of 2k. And yes, we are also making a long answer of k, so it will be O of 3k, the space complexity. And all of these things are just O of 1 operations, and we are doing just one for loop, that is O of k, and we are having the number of cells of value 0 in each subtask in O of k. So let's hit the submit button, and before it is getting submitted, so k is also 10 power 5, right? So it is the lower bound of 10 power 8, and the logic seems right to me, so it should get submitted. So let's wait for the results and we'll see for ourselves. Great. So we have submitted our code for sure, and that's it for this today's video. So let's meet in the tomorrow's POTD streak of day 111. And till then, few last thing that this is my DSL repository. You can start and hope to get help with the source code, as well as you can connect me here in Instagram as well as on LinkedIn to, if you have any doubts or guidance, if you may have, and if you have any doubts still remain regarding this question, do not hesitate to ask in the comment section, right? Because then only we learn, grow, and so that is it. We'll meet tomorrow for the next POTD streak. And till then, take care, bye bye, keep learning and keep growing.